Hello everyone and welcome to episode 6 of Building Threat Detection Lab from Scratch series. Today we'll be focusing on a different aspect of building threat detection labs. In the last few videos we have made detection labs where we have actually focused on endpoint based telemetry, but what we are actually lacking in these setups is network side of things, right? So today we'll be deep diving into network detection and response tools, and we'll try to set up some network detection capability, network response and detection capabilities, so that we are able to have visibility on what's happening on the network side of things and can build on top of it, right? So there are multiple tools available on network side, and we'll see how we can utilize or find the easiest way, right? We need to find an easiest way to set up all of them so that our detection lab has that capability, with minimal time investment, right? So let's quickly get started. So what we had set up is OS query, Elastic EDR, Sysmon Packet Beta, and Windows native logging. I think we also had installed Cribble, Splunk, Elasticsearch, and set up integration with between all of them, and that has actually helped us achieve the endpoint side of things. So I'll just recap that. But moving on, what we really want to have is a basic network based monitoring solution. And if I had to just summarize what all we need is, basically we need a standard PCAP file processing system that captures raw PCAP and allows us to process, filter, and search between it. We need Zeek for rich network telemetry and analysis, and we need some kind of a solution as an IDS or a network detection tool, and Suricata was the perfect tool for it. So if you see, Arkime, formerly known as Moloch, or Suricata, and Zeek are three basic and most important tools in any network detection arsenal. So what I've done is we'll try to set up all these three, and we'll, if it's best if all of these data is centralized somewhere, as in it is done in a SOC, right? So security operations centers tend to centralize all the data into their central SIM solution. So what we really also wanted is to centralize all of this data via some log shipper. If we can send all of these data somewhere where we have capabilities such as dashboard filtering and querying, right? So again, our SIM could be utilized here, or you can set up a separate SIM for it. But while doing the research for setting up all these three solutions, I stumbled upon another solution known as Malcolm, and it was really awesome. The tool actually picks the best network monitoring solutions such as Arkime, Open, Zeek, Suricata, Yara, Kappa. Yeah, you must understand there are some other solutions also included which are endpoint based, but as you can imagine, files to get transferred over network, right? So Yara running on network file transmission could be helpful. So yeah, from that perspective, we have Yara, Kappa, ClamAV, Cyberchef for data conversion, um, and all of this also integrated in a neat fashion to OpenSearch, um, and uses Logstash and a lot of different Yara signatures, plugins. Everything is neatly wrapped up. So if I had to just show you the diagram of what is included, you can see that um, it has capture and analysis section, which includes Zeek, Arkime, Suricata, NetSniff, NG, TCP dump. And then it has file scanning capabilities using Yara, ClamAV, Kappa, and VirusTotal. It will ask you to insert a VirusTotal API key if you want to use VirusTotal. Forwarding of the data from these two layers is taken care by Fluent Bit, Logstash Beats, and the storage happens at OpenSearch. You can plug in your own Elasticsearch or OpenSearch cluster, or you can ask it to set up a new one, and it will set up a new one. It utilizes OpenSearch's own anomaly detection alerting plugins. It uses Netbox as a management solution, so it can plot graphs between networks and IPs for asset management. Again, visualization is supported by OpenSearch dashboards and Arkime both. We get Cyberchef for analysis or conversion of that payload or data from one format to another format. And we also get Wireshark. And all of this is supported via frameworks such as Docker, Nginx, or Kubernetes. So a really neat solution packed together, which is easy to install. So, for the sake of setting up the NDR capabilities or network detection capabilities as part of the lab, what I have done is I have set up a separate box. Um, Also, you should understand network detection and response is a heavy component, or a set of heavy components that come together. So you should really need to have some beefy hardware to run it. So, if you are also running the threat detection lab along with it, say for example, if you just imagine, the logging server here takes 8 GB of RAM, firewall takes 2 GB, Windows takes 4 GB. So we are spending at least 15 to 20, 16 GB here. This box will host all of these tools, right? So it would at least need 8 to 12. Ideally it is recommended to have 16 GB, but 8 to 12 uh, is something that you should minimum put into that virtual machine. So if you're having 32 GB of RAM, uh, it would work out in your favor, and go ahead and set it up. If you're not having enough RAM, I would ask to try to reduce these load on these by actually turning them into some cloud workloads, right? For example, in the logging server side, if you can convert one of your SIM to some cloud-based logging solutions such as New Relic or Grafana, you don't have to run a sim, so you can reduce the RAM utilization here and get some extra RAM to run here. Ideally, if you need one sim in the cloud, so you move data to one sim in the cloud, and you can ideally remove this entire virtual box out and utilize the 8 GB RAM that you get from here to run the network detection and response components. So that could be a strategy that you can implement, but for now, what I've done is I have set up a separate box that I'll use to set up network tools and integrate all of that together. So what happens if you are using VMware Workstation is you don't get um, Promiscuous mode enabled by default. So that is something that you will have to enable by yourself in the configuration file of this virtual machine. So what we'll do is we'll just log in first and shut down. Okay, so our VM has shut down. What I'll do is I'll move this to our folder and rename this to Malcolm, or let's say network detection and response box. And we will go to open VM directory. Okay, you would have a malcolm.vmx file. This is something that you need to edit. Okay, it's a configuration file, as you can understand, with a lot of parameters. What we need to do is basically enable promiscuous mode as a parameter, and that is done via use of a parameter. So basically your internet or ethernet network number dot no promisc. So we'll just copy this and we'll search for ether. Okay, so mine actually uses ethernet 0. I'll just paste that. Click on save. So this is saved. I can exit. Cool. Now if we run this machine, promiscuous mode should be enabled on this virtual machine. So there are two ways how you can install Malcolm. If you go to quick start, um, you can basically build from scratch, or you can also do an ISO based installation. um, yes, you get an Malcolm installer ISO that you can use to do an ISO based installation. What we will do is basically we'll do an installation on Ubuntu 22.04 LTS. Okay, so installation use on Ubuntu 22.04 LTS is something that we'll do. However, I am running 24.04 if I am not wrong, but the installation steps should be same, so shouldn't matter that much. Um, Going back, what it does is it asks you to basically get the required files from the Git. So let's go to Git. Let's follow the entire process inside the VM. This is bridged. The VM is running in bridged, I believe. Yes, the VM is running in bridged. So let it be in bridged and run the entire process inside the VM. Malcolm network documentation. um, Quick start. Okay, let us start setting up. We'll just do the git clone first to get the repo clone and get the necessary files. Cool. Now that we have the files, we can actually start installing. So what we'll do is we'll do /scripts /install.py. Okay, Malcolm process will run as UID 1000. Yes. We'll rename the node as ndr Malcolm. Run in the Malcolm mode or hedgehog. Let's do Malcolm. This is the place where you actually get an option to plug in your own OpenSearch or Elasticsearch instance. For the sake of this setup, I'll just use a separate OpenSearch instance. Basically Malcolm's own OpenSearch instance, so I'll just say yes. Compress local, and we'll leave everything as default. Compress local OpenSearch index snapshots, no. No. It says that it will use 4 GB of RAM for OpenSearch and 2 GB for Logstash, which is too much. So we'll just change. We'll say use 2 GB for OpenSearch and 1 GB for Logstash. Yes. 3 worker pipelines. Okay. Restart Malcolm upon system or Docker daemon restart. Will leave no. Require unencrypted HTTPS connection. No. Yes, this is a lab, so we can afford this. No. Okay. So authentication is none. Save the file on the drives. Yes. ILM, no. Oldest database indices and capture artifacts based on available storages. No. Do not delete. Automatically analyze with Arkime. Yes. With Surigata. Yes. Auto update is disabled. pcap file with Zeek, yes. um, Monitoring OT or air gapped. If you're installing this in air gapped environment where you don't have internet, you can select yes. Otherwise, we'll keep it no. Perform reverse DNS lookup locally, no. Hardware vendor OUI lookups for MAC addresses, say yes. String randomness scoring on some field, yes. Uh, from a different sensor, yes. It should accept logs from different sensor. File extraction with Zeek, yes. Known mime files. uh, File preservation all. um, Exposed web interface, let's say no. Scan extracted files with clam av, yes. Yara, yes. Kappa, yes. Virus state will no, it will ask for an API key which I don't have currently, so I'll say no. Download updated file scanner signatures periodically, auto update, no. Maintain an instance of netbox, which allows you to plot graphs for networks and everything. It's a modeling tool, so we'll say no. Should Malcolm capture live network traffic? Absolutely yes. Specify interface. We'll go to a new tab and we'll say if config. ENS33 is the interface on which I have got an IP, bridged IP, and this is what I want to monitor. So I'll say ENS33, say OK. Dark mode in OpenSearch dashboards, why not? Pull Malcolm Docker images, yes. Now this is where it actually starts pulling the Docker images of all the tools that it has to configure before it starts configuring them. So if you click yes here, you would see a prompt that is blinking here, but nothing else happening. Do not panic, things are loading in the backend. Let's go to the new tab and do docker ps docker image ls. You see there's one image already loaded, so it will start loading all of these images. We'll give it some time. I'll just pause the video for the sake of it, as it would take a lot of time to get all the images. So I'll just pause just to clear and check. Okay, Malcolm has been installed. Okay, we'll just do okay, do clear. Now that the Malcolm is installed, let us set up the authentication. We'll do /script/auth setup, configure authentication all. Okay. For local, yes. Administrator username, let's put our name. Password, let's put a password. Okay. HTTPS access, no. Remote log forwarder, no. Configure remote primary or secondary OpenSearch Elasticsearch instance, no. OpenSearch alerting, let's say no. Internal pass netbox, we have not installed netbox, so no. Store password hash secret for Arkime cluster, no. And it is done. We'll start Malcolm by running this command. Okay, so it has started running all the containers that it had downloaded as images. So if you go to a new tab and do docker ps, you would see all the containers are in starting state. Let us do free-h to check RAM, 670 MB. Okay. This will wait for each of the components to be up and running. So OpenSearch generally takes a lot of time to start, and all the other containers are dependent on it. So let us give it some time. Okay, as you can see, system is becoming a bit unstable. The RAM is very low. So when it has finished loading, it will give you this IP, or basically it will say where you can access the malcolm from. We will use the browser on my host machine to access this, because opening browser inside the VM would cause VM memory to be used. Again, I don't want VM's memory to be used. There are a lot of services running. So what you can do is just do docker ps, and you would understand there are a lot of containers running. And if I do free -h, you can see um, I have 7.8 GB of RAM still available on this machine, but better use the browser outside for a smoother experience. So what I'll do is I'll just load a browser here on my local machine, and we'll do the IP https 1.10, and you would be greeted by this screen. So we have Kibana, we have Arkime, we have Netbox. I think we have not configured Netbox. We have Kibana, Arkime, Cyberchef. Let me just validate Netbox. I think yes, Netbox is not configured. Kibana, Arkime, Cyberchef, documentation, artifact, upload features, local management layer, and APIs. So we'll quickly jump into Arkime to understand what all features do we get as part of Arkime. You can see here Arkime is super rich network monitoring solution. So you get a lot of data here. You can see we are in the session mode. Session tab on the top is selected. That means we are capturing sessions between the two nodes that are talking. And you can understand, if you click on this plus little plus icon, all of the session details including the network parameters are captured. But if you scroll down, you would see also the full packet is captured, right? So you have visibility into what happened in that session, and you also get the capability to download the packet, right? If you see here, you can download pcap, you can download source raw pcap for the session, packets for the session, right? You can tag it, you can remove tags, you can export the pcap. All of those features are available, and this makes this tool as good as any network detection and response tool, because you now have access to the data. So you are free to write any kind of direction and response rule or a hunt rule on top of it. We'll come to that, but this is the view where you get all of that data happening here. You see all of the transactions between, this is my windows virtual machine. So windows contacted microsoft.com, and that is also captured here as a session. So I can drill down, understand what happened. Also, if you see the parameters closely, you will see there is JA4, JA4S, JA3S, JA3. That means it is using JARM as well. Now, what is JARM is a good question. So let's do Salesforce JARM. So JARM is basically a tool that was given by Salesforce, and is can help you identify servers that have the same TLS configuration. Now, how does it actually help in security is, you can identify servers TLS configuration and map it to different C2s that are running the same TLS configuration. Say for example, I host a C2, let's say Partial Empire, a post compromise framework host written in PowerShell. If I host this, that the TLS configuration of that server would be same across all the PowerShell Empire that are not tweaked. So JARM could be helpful to identify if this server is running PowerShell Empire. So it's fingerprinting basically, right? So you have fingerprints of JARM also there. You have certificate values, you have TCP flags. So everything, anything and everything that a network parameter has is captured here, and also the raw packets. So it's amazing that it captures so much of data and gives you in this nice beautiful view. We'll quickly jump into the next tab, that is connections. If you click on connections, you would realize is that it builds a graph of communications that are happening. The query size here currently set is 100, and that is why you are seeing a very small graph. But if I make it 500, let it load, you see the amount of node query that was done was for 500, and the graph increased. Imagine if I do 5000, I think the graph would be too big, right? You can see here the graph is too huge. So all the network communications were queried, and basically there was a limit of unique 5000 on which this graph was plotted, right? So this is really helpful if you're trying to use visualization to determine if there's an anomaly. For example, if you see this, there's an anomalous IP 0.0.0, which was contacted only once, right? We understand this is a loopback connection that might have happened, but similarly there is a separate graph that was happening. So this node have no communication with this node, but has its own separate graphs, a central node and different nodes. So this is also really awesome feature that is offered as part of Arkime. We'll quickly go to the next tab, that is Hunt. And Hunt offers you ability to create detection rules, right? So for example, I can create a packet search job. I can give it Hunt for ABC a name, um, how many sessions to be examined, if there's a notification to be sent when detected, and also it will help you write the detection logic either in ASCII, ASCII case sensitive, hex, safe regex, safe hex regex, right? And you can just create it and a rule will be created. So whenever there is a packet match, it will give you an alert if the notification is configured, right? Pretty neat and pretty great feature for hunting over network packets, right? You also get files, that the pcaps that are available in the backend. I think if you have access to the server, you can go to this location and download the pcap or use the pcap for your own usage. We also get stats is nothing but the statistics around the servers, their usage, elasticsearch usage, sharding and everything. And you get history, which are basically audit logs, what all did I do as a user on the platform. um, and you get settings and user configuration methodology, right? Or user configuration page where you can configure more users. So this is really good. Now let's go come back to session and we'll let it load. Meanwhile, let's jump to our Kibana. We'll go to discover, and you would see that there is a new index Arkime session 3 hyphen star that is populated. So Arkime installation will take care of populating this index and shipping data to this index via logstash. That is working as a worker docker worker node on the instance. So you can see here all of that information that was present there is now also available here as a log. So you can write your network detection here if you're not doing a packet based detection, right? For packet based detection, you need to go to Arkime and Hunt and create a packet based search. But if you're not doing packet based search, but are you working on with the metadata or the flow data with that comes along with it, you can use this Elasticsearch instance to write your rules, right? You can go to rules and start writing your detection rules that you would want to configure on top of this index. All of that data, all of that JARM information, all of this Zeek analyzed data, Suricata pass data, everything is available here in terms of logs, and you can use this to actually perform network detection and response, right? And the third important tab that we should cover is Cyberchef. Cyberchef is an amazing tool. You can also deploy it as a separate container and not install it as part of Malcolm. But what you essentially get is basically this amazing tool that lets you convert between formats. You can build recipes, you can build layers. You want these operations to be followed in this fashion, and you can provide an input and expect an output here. When you click on bake, it is baking something. We'll click on cancel, and there are a lot of different categories for which the conversion could happen, right? From encryption to network to packets to hashing to forensics, all of these is possible. So really amazing tool. Every cybersecurity engineer should have this tool up and running in his arsenal. Really handy for investigations. You never know when you would need this tool, or need there is a requirement to convert URL decode, URL encode, all of that to be done, right? Or base 64 conversion for a partial script that you might have received. So use this tool in your day-to-day life, and it would become an indispensable part of your arsenal. So I'll wrap this video here. In today's video, we have set up Malcolm, which is combination of multiple network detection and response tools. So Suricata, Zeek, Arkime, packet capture, Cyberchef, all logging back to Kibana or OpenSearch or an Elastic instance. Gives you ability to upload artifacts, right? And upload the PCAP file to analyze it here. And this enables your lab to now have network detection and response capabilities. So I hope this video was helpful and this tool would be a good candidate for your network detection and response arsenal. I hope to see you in the next video, where we'll be doing more integrations and we'll try to finish up with more automations and SOAR integration in our lab setup. I'll wrap this video here. See you in the next video. Thank you so much. Bye bye.